Hello and welcome back to another video. In this video, we're going to discuss all about salts, what are the rules for solubility when you're considering salt, what are different methods when you have to prepare salt, and then finally we'll discuss some exam style questions. In the previous video, I have discussed all about acids and bases, what's the difference between them, what are their reactions, and so on. If you're interested, I have linked the video in the description below. Do check it out and let's start. So let's start talking about salts. You have studied acids and bases in the previous video. What is salt? Now, we can define salts that when acids and bases combine together, they form an ionic compound, which is called a salt. So this is how you can define salt: ionic compound formed by the reaction of an acid with a base or alkali. What is the difference between base and alkali? The only difference is that alkali is a base which is soluble in water. Okay, a base may or may not be soluble in water. That's it. Now this is so this ionic compound is a salt. So for example, if we have an acid, hydrochloric acid, which reacts with an alkali, sodium hydroxide, what happens is that we get sodium chloride, NaCl, plus water. Remember, when you're naming salts, you have to take the positive, Na plus, the cation from the base, and the anion, Cl minus, from the acid. Okay, so this will form your ionic compound of salt, of sodium chloride. Now, there's also another way to define salt. Is, for example, if you have an acid, for example, sulfuric acid, H2SO4. When you replace the hydrogen in the acid and replace it with either a metal or ammonium ions, you get a salt. For example, if you replace this with a metal, for example, calcium, what do you get? Calcium sulfate. That's a salt. What if you replace this hydrogen with ammonium? What do you get? Ammonium sulfate. So this is going to be NH4 NSO4. Remember, sulfate has oxidation state of -2, and NH4 has a plus one, just plus one. So we'll do this, and we'll put a bracket here and write 2. So this is also a salt. This is known as ammonium sulfate. This is calcium sulfate. So these are two ways to define a salt. Now these are different reactions in which you can get salt. This one is discussed in detail. These reactions are discussed in detail in the previous video. So in neutralization, when the acid reacts with base, or when an acid reacts with alkali, you will get salt and water. These are some of the equations. For example, here sulfuric acid reacts with copper oxide. Remember, metallic oxides are basic. For example, copper is a metal, so this is basic. Now in case if this was a non-metallic oxide, for example, sulfur dioxide, that is acidic in nature. Okay, so you'll get salt, copper sulfate, and water. The same thing happens for alkali as well. And we'll study in detail about their separation techniques, how do you get pure sample, and all of that, which techniques you should follow in a short while. Now, neutralization, this one is not the only way through which you can get salts. When acid reacts with metals, metal carbonates, metal oxides, or ammonia, you also get a salt. For example, when acid and metal react, you get salt and hydrogen gas. When acid reacts with the metal carbonate, you get your salt plus carbon dioxide and water. With metal oxide, you get your salt and water. You basically have to balance your equation, right? And then when it reacts with ammonia, you get ammonium chloride. Okay, so these are some ways you can get salt from an acid. Now sometimes you might see like equation like this. For example, sodium hydroxide and hydrochloric acid react and you get a salt, but with this salt you write aqueous. On the other hand, you are reacting your acid with barium, for example, but now you're not writing aqueous here anymore, you're writing solid. Now, how can you identify whether you're going to write aqueous or solid? Depends on certain rules, and you have to memorize them. Basically, you write aqueous when the salt is soluble in water. When the salt is not soluble in water, you have to write S. It's solid, because when they will react together, you will get some solid that will form. Okay, so these are the solubility rules for salts. Okay, so all metal nitrates are soluble. For example, if you have magnesium nitrate, this is going to be soluble in water. Now I wrote 2 here because Mg is +2 and NO3 is minus, so you just bring them like this. Any salt that has nitrate in the end is going to be soluble in water. Now what about chlorides? All chlorides are soluble except silver chloride and lead chloride. So for example, if I write sodium chloride, NaCl, this is going to be soluble in water. But what if I write lead chloride or silver chloride, AgCl? This is going to be insoluble in water. Okay, that's it. All sulfates except lead, barium, and calcium are soluble in water. So for example, if I write barium sulfate, BaSO4, Ba also has +2 state and sulfate also has -2, so they will cancel each other. This is how you write the formula. Barium sulfate is going to be insoluble in water, okay? And then all sodium, potassium, and ammonium salts are soluble in water. Now, so we just talked about nitrates, chlorides, sulfates, and these salts. These are they have their rules, right? But what about carbonates and hydroxides? They are generally considered insoluble, okay, except sodium, potassium, and ammonium salts. Okay, other than that, if you have one of these are soluble. Other than that, these salts would be insoluble, except calcium hydroxide, which is partially soluble. Now this is test time. Can you try to identify which of these are soluble and which of these are insoluble? If you are done with this, let's do this now. Now there are different methods when you have to prepare different types of salt. So first we'll consider two methods to prepare soluble salts. Okay, so the first method is known as titration. This might be very familiar to you guys. So titration is used when your acid is being reacted with either an alkali. Alkali is a base which is soluble in water. For example, let's say sodium hydroxide. That is an alkali, or with a soluble carbonate. What type of carbonates are soluble? Remember, all carbonates are insoluble except sodium, potassium, and ammonium. So we can say, let's say potassium carbonate or sodium carbonate. They're both soluble in water. Okay, so when you titrate them, you get salt and water. This is the basic method for titration. So first you have a conical flask, and using a volumetric pipette, you add a known amount of acid into your conical flask. Now what is a volumetric pipette? So volumetric pipette is, for example, let's say you have this pipette. It can only contain a fixed amount of volume. For example, if this is 25 centimeter cube volumetric pipette, it will only contain 20. It only has the measurement for 25, not 24, not 21, only 25 centimeter cube. So using this, you only add 25 centimeter cube of acid. Now of course this is going to be colorless, so you need to add an indicator. Then you take a burette. You fill that burette with your alkali or sodium carbonate, and then you mark the initial reading. Let's say this one is 25, so 25 centimeter cube, for example. And then you titrate it. You open it, and then drop by drop, the alkali or the soluble carbonate falls into your acid. Now after every drop, you have to swirl it, okay? Because sometimes it doesn't mix properly and you wouldn't be able to see the color change. So you have to release it until the color changes. That means it has been neutralized. The acid has been neutralized, and you get your solution. Mark the final reading. For example, if this says it's 30 centimeter cube, so you have to subtract both of them. That means a total of 5 centimeter cube of the alkali has been used in this reaction. So this is your solution of salt and water. You have salt and water. So the next step is you have to evaporate it to remove the water and crystallize it. Then evaporate and crystallize. Now before evaporating and crystallizing, you have to repeat this experiment without using the indicator, because you don't want your indicator to be in the final solution, right? So using these same volumes, titrate it again, and then you can evaporate and crystallize. Now another method is that you can add activated charcoal into the final solution. So what happens is that activated charcoal, it can remove the colored indicator. So you can either do activated charcoal or repeat the experiment without using this indicator. Okay, there are basically two purposes of titration. The first one is to prepare soluble salt, just how we did here. Another purpose of titration is to find the concentration of acid or alkali. When you know the concentration of one of them and the other concentration is unknown, so you titrate them together, and using the equation and moles formulas, you can find the unknown concentration. Another way to prepare soluble salt is as follows. So when you have an acid and you're reacting with your acid with either an insoluble base, remember soluble bases are alkalis, so this is an insoluble base, or an insoluble carbonate. Remember, sodium, potassium, and ammonium carbonates are soluble. Other than that, all carbonates are insoluble. Or if you have a metal, acid plus metal, when you're reacting them together, you will get salt plus and so on. Okay, it depends on your equation. When you react them, this is the process you have to follow. But before we move on to the process, remember these substances must be in excess. Why are we using an excess of metal, excess of base? This makes sure that all of the acid gets reacted, and then you can just filter out the insoluble substance from the solution. Here we have copper oxide. This is in excess amount. It's added into a nitric acid, and then you have to stir it. Sometimes it's also a good idea to heat them. Not boil them, just heat them to low heat so that it will increase the rate of reaction. Okay, and then after you have filtered out, remember we have excess of the insoluble substances, right? So you can easily filter them out. So when you pour your solution through this filter, salt solution will filter out in the filtrate, and your residue would be the unreacted base or carbonate or metal. Okay, so after you have reacted that, you will get your salt solution. You have to heat it to evaporate the water off. So you can use a water bath, for example. When you heat it, you will start noticing that crystals have started to form. That means it has reached crystallization point. When it reaches the point of crystallization, you will remove the heat. You will leave this solution at room temperature so crystals start to form, and then you have to filter them, wash them with a little bit of distilled water to clean them, and then dry them between filter paper or tissue paper in order to get pure sample. Now when you're carrying out this experiment, you have to make sure that you wear eye protection throughout, wear eye goggles, wash your hands after handling, and don't of course ingest these chemicals. While carrying out this experiment, you have to make sure that do these react safely together. If they react very violently, it's not going to be safe to carry out in a lab. Okay, now I've written a balanced equation for this process where nitric acid is reacting with copper oxide and you get copper nitrate and water. The state symbols are given as aqueous for the acid, copper oxide is a solid, and then you get an aqueous salt because this is soluble in water, right? All nitrates are soluble, and then water is a covalent compound, it's obviously a liquid. Now let's write down the ionic equation for this. So we have 2H plus 2 nitrate ions, NO3 minus. These are both aqueous, right? And then we have copper oxide. Copper oxide is going to be written as is. This is a solid. And then afterwards, copper nitrate, Cu becomes an ion, Cu plus 2, aqueous. And then we have 2 nitrate ions, NO3 minus. And then water remains as is. So now let's if you notice, some ions remain same before and after. Look at nitrate ions before and after, there is no change, they're both aqueous, so we can cancel this. And yeah, so any ions that remain unchanged during a reaction are known as spectator ions. So here nitrate ions are spectator ions, they're not doing anything, they're not changing during the reaction. Now let's write down the net ionic equation. So net ionic equation does not have the spectator ions, all right? So we're left with 2H plus aqueous, and then copper oxide solid is going to give us Cu plus 2 aqueous plus water. So this is your net ionic equation. Now, remember here we are going to crystallize our solid, right? We are going to crystallize our salt. Now sometimes when crystallized, many salts contain water that is chemically combined onto them. I'll give you an example. So these salts are known as hydrated substances. These are substances that is chemically combined to water. For example, let's talk about copper sulfate. CuSO4 is chemically combined to 5 water molecules. This is a hydrated substance. Now when you're heating them, you have to make sure that you don't heat them too strongly. If you don't heat them gently, this copper sulfate will turn into an anhydrous substance or a powder. It's not a crystal anymore. So this is something that you have to take care about. Don't heat. If you heat it too strongly, you will lose the crystal, and you will get an anhydrous substance, which is a substance that does not have water combined onto it. This equation is representing the change. So here we have hydrated copper sulfate crystals, which is chemically combined to 5 water molecules. When you heat them, it loses its water as water vapor. Okay, notice this is a gas, and your copper sulfate becomes anhydrous. Now if you add water back into this copper sulfate, you will get hydrated copper sulfate again. Now with these substances, you also observe a color change. This hydrated copper sulfate was blue in color. Anhydrous copper sulfate is white in color. Also remember that copper sulfate reacts with is combined with 5 water molecules. Now we have another example. This is cobalt chloride. It combines with 6 water molecules. When you heat it, it becomes anhydrous cobalt chloride. The color change is from pink to blue. Okay, so now let's introduce another important point, which is water of crystallization. Water crystallization is basically the water molecules which are present in the hydrated crystals. So for us, these are the water of crystallization. And that's pretty much about it. We get these different colors because these are transition metals, right? That's why. Okay, now let's move on and talk about preparation of insoluble salts. Okay, so what is an insoluble salt? Insoluble salt is something that does not dissolve in water. You can also say that this is a precipitate, which is basically the insoluble salt formed during a chemical reaction. For example, if you carry out your reaction in this test tube, you will see that both of them react together, and then you might see something shows up at the top. Okay, this is the precipitate and does not mix with the water. So this is the precipitate and this is insoluble. So how do you do that? You have to mix 2 aqueous solutions or soluble salts that provide us with the required ions for your salt. Let's look at an example. Remember, lead chloride is insoluble, so this is solid. Therefore, you need to have 2 substances here that provide us these ions. Okay, and these should be aqueous. So what about lead? Let's react lead with nitrate. Let's have lead nitrate. Remember, all nitrates are soluble, so this one is aqueous. And then the second ion that you require is chlorine. So we can react this with sodium chloride, NaCl. Let's balance this to NaCl. This is also aqueous. So you have two soluble salts here. This will give you lead chloride and then sodium nitrate plus NaNO3. This is also aqueous. So here you get your precipitate. Now if you want to filter, now you're going to filter this out and then wash it with distilled water to remove any traces, and then you're going to dry this between filter paper. Okay, this is important. Filter, wash and dry. Now let's have a look at another example. Barium sulfate, BaSO4. Remember, all sulfates are soluble except lead, barium and calcium, so this is going to be solid as well. Now you want barium, so you also want sulfate ions. So now let's react this with a salt, soluble salt and an acid. Okay, you can even use an acid. So let's use sulfuric acid, H2SO4, and then barium chloride. So you will be left with, you will get hydrochloric acid, which is aqueous here. Now you have barium sulfate. You can again filter, wash and dry to get your clean sample of barium sulfate. Can you write down the ionic equation for this? This is simply going to be BaSO4 solid would be Ba plus 2 plus SO4 minus 2. Now why am I not writing the spectator ions? Because they are same. There is no change. This was chlorine was Cl minus before as well as after. It was same. So and hydrogen as well, it was H plus and then H plus. There is no change, only barium. The only change is this. So this is the ionic equation. Alright, now let's have a look at these exam style questions. Let's read the questions together, and I encourage you to solve these questions on your own first. And if you are done or if you are stuck, let's start. So the first one is based on preparation of salts. Describe how you're going to prepare a dry sample of copper sulfate crystals starting from copper oxide powder. Remember, your method for preparing salts depends on whether or not your salt is soluble or not soluble. So what is copper sulfate? All sulfates are soluble except lead, barium, and calcium. So this is soluble. This is a soluble salt. Now, do you carry out this with titration, or do you react them together and then filter and crystallize? Titration is only when you have acid and alkali or another soluble carbonate. But now you're starting from copper oxide powder. So you have copper oxide and you need to get copper sulfate, CuSO4, aqueous. So you can react this with any kind of acid, with sulfuric acid. So this is going to be H2SO4. This one is in solid and aqueous and so on. So now let's look at how they answered it. So first, you're supposed to add excess copper oxide to dilute sulfuric acid. Remember, your solid must be in excess. Warm gently until reaction is complete so that it speeds up the reaction, and filter to remove unreacted oxide. Remember, our copper oxide was excess, so anything that's not reacted will be filtered out. Then you're going to evaporate the solution until concentrated. Remember, look at this equation, you also have water. So you have to first you can heat it to evaporate extra water, and then you're going to leave, and then you will see that crystals have started to form here in the solution. So that means you have reached point of crystallization. You will remove the heat and you will leave to cool and allow it to crystallize. Then it's a good idea to wash it with distilled water, and then dry the crystals using filter paper. What's the next question? Explain why excess copper oxide is added. This was excess, right? This is to make sure all of the acid reacts and you don't have any unreacted acid. What about a balanced chemical reaction? Here, this is the balanced equation, which is also written here. Okay, let's move on to question number 2. State whether the following salts are soluble or insoluble in water. Take a moment to solve these. And if you're done, barium sulfate is insoluble, so I'll just write across. Sodium carbonate is soluble. Silver chloride is also insoluble, and potassium nitrate, remember, all nitrates are soluble. Now, which method, precipitation, titration, or reaction, it's a simple reaction, is best to prepare sodium sulfate crystals? So to do that, you have to wonder, is this soluble or insoluble? Sodium sulfate is going to be a soluble salt, right? This is soluble. So soluble salts can be prepared by titration or reaction with acid plus insoluble base. Let's write down the reaction through which you get sodium sulfate crystals. So you have Na2SO4. So this might be reacting with NaOH plus H2SO4. So this is titration. So a sodium hydroxide plus sulfuric acid to give you the salt. So this is just titration. Lead chloride, remember, all chlorides are soluble except lead and silver, so this is insoluble. Therefore, you have to do precipitation, which is given here. Two soluble salts form an insoluble salt. This last question is about crystallization and calculations. If you guys are familiar with moles, you can try to do this on your own. Let's do this together now. So a student prepares hydrated magnesium sulfate crystals, which is given here. Now, if you notice, we don't know how many water molecules are chemically combined to magnesium sulfate, but this is a hydrated crystal, right? Because water is present. What is the mass of hydrated salt? It's 12 grams. So initially, when you had magnesium crystal sulfate and then you measured the mass, you got 12 grams. And then you're heating it to a constant mass. The mass after that is 5.9 grams, okay? So initially, this had 12 grams. When you heated it to a constant mass, all of the water has been separated and you have anhydrous salt, right? This one has only 5.9 grams. So you're asked to calculate the value of X, this one, how many water molecules are basically chemically combined to magnesium sulfate. In order to do that, first we'll find the moles of magnesium sulfate and water, and then using ratio method we'll find the number of water molecules. The ratio would be with 1 mole of magnesium sulfate, how many water molecules are present, and then you will write the moles there. So let's find out the moles of water. To find the moles of water, you need to find the mass of water, right? So mass of water is going to be 12 minus 5.9. This equals to 6.1 grams. Why? Because it was 12 grams and then after the water is gone we have 5.9 grams. So the difference between both of them is the mass of water. So now you can find the moles of water. Remember, moles equals to mass over mR. So 6.1, divide this by mR of water is 18. You will get 0.339 moles. Now let's find out the moles of magnesium sulfate. So what is the mass of magnesium sulfate? It's 5.9. So 5.9 divided by the mR of magnesium sulfate. It's given here, it is 120. This can be found from the periodic table. And you will get 0.0492 moles. So now let's do the ratio method. Magnesium sulfate to water. So when you have 1 mole of magnesium sulfate, you have X amount of water. Let's write down the moles. This is going to be 0.0492 and this one is 0.339. So you have to solve for X, and X would be 7. So this can be written as MgSO4.7H2O. Now the next question says, suggest why the crystals were heated to a constant mass over here, because we want to make sure that all of the water of crystallization is removed. If you still have some water of crystallization here, this is going to give you wrong answers.